email, that's fine, but I will respond to them collectively after the group assignments have been done. This is just easier for me to manage the workload. And yes, so that's actually all the housekeeping I have. So we have two things planned for today. When we talk about interactive visualization, there's one thing that we think about is the interactive plots, figures, maps, anything that we used in Matplotlib, for example. We could also do in Plotly, for example, which is one of the most popular Python-based visualization libraries, or interactive visualization libraries. We've in fact used it already quite a few times. So a lot of the kind of pipes energy balances were using Plotly in the backend. And you can think of it just as an interactive substitute for Matplotlib. You can do most things that you can do with Matplotlib, you can do with Plotly, just in a slightly different syntax, and then you get interactive plots out of that. And then the other thing people think about when we say interactive visualization is some form of interacting with the plots, some form of kind of dashboarding where you can click, select, or filter a few things. I'm going to show you one of the tools that can be used in Python for that. It's called Streamlit. And I chose, there's a couple out there. There's also one that interacts very nicely with Plotly, but I chose Streamlit because it's relatively straightforward and it's very fast to get to your own dashboard. So actually by the end of today's lecture, we will have built our own dashboard of power plants in Europe, where we can filter by technology and a range of commissioning years. So by the end of today's lecture, I hope we'll have something like that running with our own code. So let's start with the kind of basics and how we can create some of these plots first. Okay, so I brought a few downloads, which I think I've already done, but let's do them anyway. So a few kind of different types of data that we have already used in our course so far. So some geographical data, some power plant data, some time series data. And you will agree that when we just use matplotlib, that it comes with some limitations. For example, it doesn't help me figure out kind of exactly what the peak value of this time series is. With an interactive plot, we could potentially do that. So let's see how we can do that. And again, here, there are different interfaces to access the functionality of Plotly. And one that we are going to use now is the so-called Plotly Express module. It's kind of more high-level interface that has a little bit reduced functionality, but it's quite, or the syntax is easier, and it interacts quite nicely with pandas. So we can import that, or we would typically import that as Plotly Express as px, and the other things I import here, they are not really necessary. They're just necessary for the plots to also show on the course website. So that's not directly relevant for you. So let's plot kind of an interactive version of that with Plotly Express. So the syntax goes as follows, that we take our panda series here, the selection of our onshore wind capacity factor time series, and we say px.line and pass our series and get this interactive plot out of that. And here it's relatively straightforward to see both the exact date and the value of the peak. And everything else we can do, we can pass a subset of the series, of course, but then like we did in some of the pipestar settings, we can also, we can zoom in, and ideally we just zoom in like this, for example, into a particular week. Okay, what else can we do? Let's take a pandas data frame of our power plant data, the power plant matching data that we've been using throughout the course. And let's just restrict it to hard coal power plants, just so that we don't have too many. And previously, when we did the static plotting with GeoPandas, we first had to convert the power plants based on the latitudes and longitudes into a GeoPandas data frame. For Plotly Express, this is not really necessary. You can just pass the columns of the latitude and longitude. So you can just pass there's a function, scatter mapbox. So scatter is just, scatter plot of points of varying sizes. And Mapbox is a tiling service for a layer like from Google Maps or similar in the background. So some geospatial orientation. And then we can specify which column would represent the latitudes, which column would represent the longitudes. We can select, there's a range of different selections, how we want our background layer to look like, the zoom level and the height of the figure. And then we get a plot like that. And it's a scatter plot, but there's relatively sparse information now here. So how can we make that more useful? Well, we can add a few more arguments. We can add the size argument, which would size the markers by the capacity. And we could give a color argument, which colors the markers by their date in, so the start date, the inaugural operation date of the power plant. And then we get automatically a plot like this, where we can see kind of individual power plants and what their build years, date years are, and the capacity. So that's for scatter, for point source data, like power plants. There's also a similar function to plot background layers of shapes. So if you think back to one of the assignments, the nuts shapes, the administrative regions, which we have loaded here as a GeoPandas data frame. And we want to maybe color that in different colors. We can do that like this. So some of the arguments here overlap, some don't. So for example, what this choropleth mapbox needs is a GeoJSON argument, which takes just the geometry column of our geodata frame. We can give locations, which would just be the index of our geodata frame. The mapbox style and the zoom and the height are all the same. We want to color by country code in the absence of any other interesting data. And what we can also do, and that's another style parameter, is we can choose where we want our plot to be focused. Yeah, so here we just get a different color for each of the different countries. Not super exciting, but you can imagine if you have any other column with more meaningful data, you would just get colors here. And this is a categorical data set, so it would just be categorical. If you have floating point values, you would get a scale on the right-hand side. Okay, good. Let's go to a network, a pipestar network, where we look at the dispatch, and in particular, we only look at the kind of positive side of the dispatch. And for that, for the plotly express function, I needed to bring that data set into a specific format, so-called long format um, in tables, where I have no index anymore, but I have one column for the x-axis. I have one column for the categories, so the technologies, and I have one column for the concrete values to be shown. And then if I use the px.area function, what I can do is I can pass our data frame, say our x values should be the snapshots. The elements of the area should be colored by the name, the technology name, as y coordinates, so our values. We want the gigawatts column. And then we also want to group by name. So that's the way we tell Plotly that we want this to be a stacked graphic. Yeah, and with all these area charts, it's always useful to have zero line width because, yeah, it looks nicer. So that's what the second line is about, to update so-called traces of the lines. And when we run that, we get a chart that looks very similar to what we nowadays get out of the box from N statistics, energy balance from Pipezone. It's a relatively new feature. Okay, good. So how do we go now about these interactive dashboards? So let's see if our dashboard is running by now. No? Then we just do it ourselves, I would say. For that, I will briefly switch to a different repository. That will just take a second. So what did I do? So I entered a new repository. This is really relatively basic setup. There's actually not too many interesting files in here. There's some file that manages the requirements here using pip, but could be a conda environment. And there's an app Python file, which we're going to work with and actually import Streamlit here as T, and the rest is just configuration. There's actually not much information there. Maybe we'll look into it, but at the core, we just have a single Python file and Streamlit installed. And now in the command line here, I have activated the environment where Streamlit is installed. And I set Streamlit run app.py. And that does something similar as when you run your Jupyter notebooks, for example, you get this kind of app under a port 8501. So this runs locally, and we can look here what's happening. So at the moment, nothing is happening, but I'll put just these two things side by side so that when we change stuff, we can see what's happening. So I can make some balloons show up, for example. So it asks me now, oh, okay. Well, let's set that up so that you can see that as well. How far down do I need to go? Like this, maybe? Yes. So what you see here is it noticed a file change and asked me, should I rerun that or not? And let's just say I trust my own code, so let's always rerun. And the principle in is basically that the whole Python script is re-executed with any change. So if I just add a space here and save the file, we can see more balloons showing up. So the whole script is re-executed. Okay, what we can do, we can, for example, give this a script a title, and we get the title, and we can use things like Markdown syntax here or use the specific building blocks like a title that Streamlit provides. And I mean, in all this, we want to present some data of the power plants in Europe. So what we'll definitely need to do, we'll need to import some data from some URL, and I think I have that URL stored somewhere. So, and let's work with good code style. Let's put all the imports at the top and store this under the name df. And we can just dump the df here. And if we now, oh, it's not. So if I now save this again, we get the balloons showing up. And I have the dataset also being displayed here in just the kind of the raw format. And the problem here is that it takes a moment because with every re-execution, this data frame is re-downloaded and reloaded and presented. So what Streamlit provides is that for recurring tasks that are always the same, we can cache data. So we can take all our data frame handling and put that inside a function called load power plants, where we do exactly what we did previously and annotate that with this add syntax that this is data to be cached. So basically, when Streamlit notices, well, this function has already been executed with exactly these arguments. There's no need to re-download that. I have that stored in cache. So I have that accessible somewhere on the hard drive without the need to re-download that. And we can just say we call this function ppl load power plants, and that if we run this repeatedly, should be much quicker. So the first time now, it takes exactly the same time as before. And if we rerun that now, it would be a lot quicker. Yeah. So I'll disable the balloons for now because yeah, we have other plans. Good. So what can we do as well? Well, we can add a plot. So what we can do, there's a few things that we don't need. So if you think back to the Jupyter notebook we've been working on previously, we had this scatter map where we just took the color and the size and presented this map interactively. We should just import Plotly Express here. And if we want to display that figure, we can use this function Plotly chart. It's just a way to display a plotly figure. We can say we want to stretch that to the full width instead of displaying the whole table. Oop, something's not quite right. Let's go step by step. Okay, so at least we have something here. So what we maybe should do, we should maybe filter a little bit the data before we pass that to our plots. So maybe we want to create a data frame that is, let's say the fuel type is hard coal. So in this case, we would only show the hard coal power plants. And well, this is so far nice because, but there are no interactive elements yet. There's no way to select, for example, what type of data we want to show. So, but ideally we want something like fuel type, hard coal, and then we select a fuel type that we select. And this should not be hard-coded, but some interactive element. And there's a function for that, so-called select box. Yeah, so let's uncomment that. We called it tech. So we have now here a select box, which has some instructions. Select the technology. And what can it select from? Well, it can select from from the list of available fuel types. And whatever you select here, with every execution, basically with every interaction you do on the right-hand side, you get this variable tag, which you can then later use downstream. So let's see how it looks like. So what we get now is we get this small button here where we can just select one of the fuel types, and then based on what we select, the plot will update and show a different set of power plants. Good. We can also select, for example, a range of years. There's a so-called element that's called slider, where we can just select, give again some instructions, a kind of range that the slider should have, and a tuple as a starting selection, and things like a step, and there's even a help button. And that, as Copilot here suggests, we can then just use in the selection of in the filtering of our data frame. And once we do that, we get now here two sliders where, let's see, you can, for example, look at the hardcore power plants that were built since 2000. And there's a few. But this way we can now just select, and this whole script is re-executed whenever we change something in our selection. Good. All right. So what happens now if we select something like natural gas and filter to very early time period? Kind of want to drive this into an error, but there seems to be one power plant that is, let's go with solar. So yeah, so in this case, when we have no data, the plot will focus on the like 0, 0 coordinates, which is maybe not something we want to show. So we want to maybe check here if our df is empty, then we want to display an error and say there's no power plants to display, and otherwise the plotly chart. We do that, we just, instead of a random chart, we would just get an error message. In this way, we can just control the flow just with simple if-else statements that you know from, from all of the course, basically. Okay, there's one more thing that we can do that I want to show, is that we can give this plot here a little more structure, or this dashboard a little bit more structure. So at the moment, it's not making the best use of the space available. So we can introduce a sidebar, for which we can use this with block, where everything that is kind of within this block would be put into a sidebar. And the sidebar could also just have st kind of a title, could have basically all the other elements of Streamlit in there. And then I have to look that up. We can also kind of set the page configuration to the layout wide, and that will just kind of stretch the map a little bit. Right, and now let's hope. Yeah, so now our selection of colors and sizes also works. So let's do one last check. Oh, I think yeah, that's quite recent actually. So yeah, there's some batteries here, battery data that was added, and we can see where the batteries are in mostly in Germany, because most of the data is available in Germany, but there's also a couple here, for example, in the UK. Good, and I think that's it. Everything else, actually no, there's one more thing. So what happens? We can decide what information we see when we hover on these individual elements. So maybe something that we want to see is what the name of this power plant or this battery is. So we can just define a list of things we want to see, just attributes in the data frame, and then add this as hover data argument. And now, if I zoom into here, for example, then it's here the Batteriespeicher Werne, one of the bigger batteries in Germany with 72 megawatt capacity, lithium-ion battery, and so on and so forth. Okay, good. And so it's kind of a functional dashboard, I would say. So you can explore some useful information. It's relatively straightforward to host that also, although this one is sleeping at the moment. But if we count the lines of code, it's kind of 50 lines of code. So it's kind of easy enough to do, I would say. So, and that's why I chose Streamlit. It has some limitations if you want to do very special things, but it's very fast to get a prototype up and running. And I think that's where its popularity also stems from. Yeah. And that's it as far as the interactive visualization goes.